So anyhow, point of all of it, be not afraid when you read this problem and it's got a wacky picture and you're not sure what you're supposed to do. Quitting is not an option. Okay? Quitting is not an option. So to just write something down and move on is not good. All right, so let's figure out what's happening in this problem. All right, so what is happening? Shape of the square semicircle. Total area is 200. So that will be semicircle plus, is that a square? Yeah. So the semicircle plus the square. Okay, and we don't know anything else. So maybe we'll call this x. If that is x, what's the area of the square? X squared. Yeah, that's easy. Okay, now if that's x, this will be half x or x over 2. So what's the area of the semicircle? 1/2, because it's half the circle. 1/2 pi, 1/2 x squared. So let's see, that is 1/2 pi times 1/4 x squared. So 1/8 pi x squared plus x squared. Everybody okay with that? And that has to equal 200 because that's the total, that's the semicircle and the circle, or and the square has to add up to that. Now, some of you just stop there because, I don't know, some people were trying to factor and stuff. I mean, you can take out an x squared, and if I did that, what would I have left? X squared, 1/8 pi plus 1. But that doesn't really help me. I guess it could. X squared equals 200 over 1/8 pi plus 1. Are you keeping up with me? And then I could simply square root. So 200 divided by parentheses, 1/8 pi plus 1. And square root that. I got x equal to 11.984. So that's one strategy, one way to do that problem. You could also, some of you are getting stuck at this point, you could also have graphed this and graph this and look to see where they intersect. And I think you may have been having some window problems with that. I'm not exactly sure. But if the whole area is 200, wouldn't the area of the square have to be less than 200? So whatever x is, it's going to be a number less than the square root of 200. Would you agree, just to ballpark it? If you're having window issues, you could use that as a starting point and go from there. Jacob?
Well, I never got my default because I was supposed to.
Okay, I've got some with no name. You can go check over there and see if your names are on, if the one of those is yours. And I could also have gotten it mixed into another class, that's possible. But check there first. Okay, so that's that. Now, while we're here, I'll do one more problem from this homework. Is there one more from the P5 that you have a question about? Or is that the only one? So I'm trying to remember what else got this. Anything else? that? All right, well, we're here then, what about the P4s? Anything from the P4s?
Number 6 on the
P4 number 6. Okay. P4 number 6. Using the data from 97, so that would be 1997, comma, 85.9. 2003, so that'd be 2003 and 138.1. Using that data, write a linear equation. Okay, so the slope is going to be 138.1 minus 85.9. Over, that's 6. So what is that? 8.7. So my slope is 8.7. And then I'll pick a point, it doesn't matter which one, I guess I'll just use that one. Y minus 85.9 equals 8.7, x minus 1997. Now, that would be an equation to describe this data using the data points they gave me. Now, it's not very useful, but that's okay. And then I'll skip to C. C says predict the export or imports in 2022. Now, where's the 2022 going to go in this equation? In for S. So I could just leave it like this and put in 2022. Or I could rewrite my equation in so there's that form that will cut down on my arithmetic here. But anyway, 8.7 times, what is that, 25? Add my 85.9. And I get 303.4 billions of dollars. Okay? Now, this was my equation right here. In order to graph it, I need to get y by itself. So my equation, because it says I have to put it on my data points. So my equation is going to be 8.7x minus 17,288 is what I got. Is that right? If I clean this up, 8.7 times 1997, and then add 85. Yeah. So there's my equation. So to superimpose it on there, that just means graph it at the same time. I am going to graph this equation and plot all of my original points. So 1, 2, 3, 4, 5, 6, 7, 8 original points are going to get plotted. Now, because of the nature of the points, you're going to have to be careful on your window. So we go to Stat Edit, and we're going to put it in, but we got to have our X-min might be like 1990, and my max might be like 2010. I'm giving myself some leeway. Y might be 70 to 145 maybe, something like that. And then go to Stat Edit, put in all of your points. Make sure your stat plot is on, and graph. And that equation should kind of come over those points. We talked about, though, that your calculator is going to give you a line of best fit. This may not be the best line, but it is the line you got when you use these two data points. but to put it in my calculator, I did it in this form. Doesn't matter, it's a line anyway.
So I put it all, like all the information in the block thing, so that's how I got like the line best fit, so I did that as my, as the slope of my linear equation. Do you not want us to do that?
I'm gonna follow the directions. So the directions said write a linear equation using these two data points. Look at the problem. Using the data from
Okay, yeah.
here and here, yeah. Now, if you were truly doing this problem, then you would have won for line the best fit, but we are specifically practicing the skill of writing our own equations. Right. Okay, let's put that away. Other homework questions can be addressed during office hours, which by the way, I will have on Friday. I know some announcement somewhere said, we didn't have them or something, I don't know, but anyhow, I'll be here Friday if anybody wants to come in for office hours. Okay? Also, Friday is a big day in the math world. Opening day Mathly signups, okay? Over there, Mathly signups. That only goes for a week, so don't procrastinate. Bring your $4, unless you want one of the coolest t-shirts ever, and then you're going to bring $18, because these are $14. Please do that. Math League extra credit is test points. Test points weigh a whole lot more than homework points do, some of you are discovering. So, I'm not saying you should do it only for the extra credit, because Math League is just plain fun, and by the way, we are defending regional champs. So we need your points, we need your good scores, but you do get extra credit for it. Don't forget, no late signups. So, do it. All right, back to our notes now. We are ready, I think, for P7 2B. So here we go. I'm reading the directions. Directions are huge, guys. You need to do what you're being asked to do. Solve with calculator. So, take a look at this picture. I'm going to sketch that thing. Clear out my old equation, put in my new. I have no idea how my window's set. So I'm just going to go ahead and zoom 6. And now what did you get? I got something that looks like this. This parabola, that's this guy right here, this parabola, I want to know, where is this parabola less than 0? So that means, where is it below the x-axis? And it's not. So what's the answer to the question? It is never less than the axis. All right, same thing here, a little bit bigger equation. But it doesn't matter to the calculator, it can be as big as you want. So x cubed, use your little caret button, x cubed plus 2x squared minus 1. It's a little hard for me to see it. I'm not quite sure. It kind of bumps up, and I'm not quite sure if it just hits or if it goes above a little bit. What can I do to figure that out? Make my vertical window Smaller? So I think I will do that. I think I'll go to window, and maybe my line in, I might just go from -1 to 1. Was I right to be a little bit concerned about that? Because actually, doesn't the curve do something like this? Okay, so these 3 points are exactly where it equals 0. So I need to find those 3 points. So I'm going to do that right now. I'm going to second calc 0, set my bounds. And I'm going to write down what I get. You tell me if I'm right or wrong. I get -1.618 for this one. Second calc 0, that's what we're doing. I got -1 for that one. And I got 0.618 for that one. So, am I on the right track? Anybody matching any of those?
Yeah.
So we're second calc 0, because these points are zeros. They're where the function equals 0.
My line is like, it's weird. I don't know what I did wrong to make that.
Okay, so first of all, we don't have that part yet. We just graph the function. So we just graph this. So take that out. And then you get your function. All right, anybody else get these numbers? Okay, so that's where it exactly equals, which is good. I want it to equal 0, but I also want it to be greater than 0. Where is this curve greater than 0? Right here? And right here? So my answer will be bracket -1.618, comma, -1. That little interval right there. Or using my union symbol, 0.618, comma, infinity. All right, number 3, projectile motion. A projectile is something you throw up in the air, shoot up in the air. So like your football players, that's a projectile, right? Soccer players, you kick that ball, that's a projectile. Anything going up in the air like that. There is a projectile motion formula that looks like this. That's our projectile motion formula. Write that down, keep it at the top of the page. I gotta talk to Miss Green. I'm not sure if I'm gonna give you that or expect you to know it. For now, just write it down. Probably gonna not require you to memorize it, but you do need to know what all these things stand for. So this is function notation, like f of x, right? Which f of x means the value of the function at x. This is the height of the object at time t. So this is a height variable. It's like y. is your height. T is your time in seconds. V sub naught, and that's the way that is read, V sub naught is the initial, anytime you have a sub naught, it's initial, it's a starting, it's the initial velocity. And its unit would be feet per second. And then S sub naught is the initial height. There is a different formula for measurement in meters. So if I'm giving you this formula, this is the feet formula. The meters formula has a different coefficient. That coefficient has to do with gravity. Okay, so let's read our problem and see if we can figure out, this is the formula we're going to use. It says a projectile is launched straight up from ground level with an initial velocity of 256 feet per second. Okay, stop right there. You can't answer any questions without building your formula. So what is my formula going to look like for this problem? S of t is going to equal negative 16t squared. All right, plus what? What's my initial velocity? 256 t. T. And then what's my initial height? 0, because I'm launching from the ground. As opposed to standing on a cliff or on top of a building or something, right? Or even your football player throwing the football, that initial height would be, I don't know, 6 feet or something, I don't know, right? This is from the ground. So there's your equation that we're going to use for this problem. When will the height be 768? So now we have our equation. Now we're ready to answer some questions. When will the height be 768? What do you think? So 768 equals negative 16t squared plus 256t. Does that make sense? What is this variable right here? This is your height at time t. I gotta figure out what the t is that's gonna make the height 768. So take a look at that equation. What do you think we should do? It's a quadratic, so let's get the that guy over. Those are very big numbers. With my calculator, it really doesn't matter how big the numbers are. But since this problem came out of the book, just for fun, let's divide. Let's see if we can. I know 16 goes into that. Does 16 go into 768? 768 divided by 16. It does. So I'm going to divide the whole shebang by negative 16. Now, you do not have to do that, guys. If you're sitting there with a calculator, you do not have to do that. But those numbers are a lot, I don't know, more manageable. And, shoot, does that factor?
Yep.
These textbook writers I really like, they sit around and think of this craziness. Okay, so when does the ball, when does the object, whatever it is, reach 768 feet? Twice. Why twice? Once on the way up and once on the way down. So I'm going to go ahead and draw my object coming up and coming down. Here's 768. So right here is 4 seconds, and right here is 12 seconds. Does that picture make sense to everybody? So I want to know, when will the height above the ground be at least 768? So at least 768 would be here. So the answer to that question is the interval from 4 to 12. The answer to question A was exactly 4 seconds, exactly 12 seconds. Question B is the interval in between. And why is it closed? Because it says at least. When will the height above the ground be less than or equal to 768? Less than or equal to 768. Wouldn't that be here and here? So what's my answer going to be for part C? 0, comma.
3, 9, right?
Now, I think it says less than or equal to, so I'm going to go ahead and put 4. If it just said less than, I would still put 4, but I would use a parenthesis. But since it says or equal to, I'm going to do that. Or 12. Infinity? Now, what 12 to 0 doesn't make any sense because 0's over here. Yeah, I'm looking for t values, so I'm looking for t values. This also doesn't make any sense. You have to find where it hits. Because time doesn't go into infinity. I mean, it does, but not in this problem. Doesn't the problem end when the ball hits the ground? So we got to figure out where the ball hits the ground, and that's what's going to go here. This is when it's on the ground again. Well, how am I going to figure that out? Well, I erased my equation. Wasn't my original equation a negative 16t squared plus 256t? That was my original. This equation describes the height of the object. If I want to know when that object's on the ground, aren't I going to make this 0? And I can solve that many ways. One way is by factoring. So if I take out a negative 16t from my equation, the 768 isn't part of this conversation. I want to know when the ball is on the ground. So this says t is 0 or t is 16. What does that mean? It's on the ground at time 0, which we knew because it started there. And it's also on the ground at time 16. Now, I believe that some of you people probably knew that was going to be 16 before we did all that. How could we have intuitively known that, Josie?
Because it took like 4 seconds to get to that point, like 0 to 4, and it's gonna take 4 to go back down.
This shape right here, this equation right here is a parabola, and parabolas are symmetric figures. This is not a perfect model. You've got things that could be included like wind and stuff like that, but this is the best we've got, and it's symmetric. So if this right here was a span of 4 seconds, then this right here is going to be a span of 4 seconds. You can also tell me, when does the ball reach its peak? It reaches its highest point at 8 seconds. And what if I wanted to know how high its highest point was? What would you do? Take that 8 seconds and put it into my equation, and that's going to give that to you. Okay? All right. Now we got the best problem of all time, the box problem. I need everybody to get a scrap piece of paper, please. Something that you don't mind if it gets ripped up. So sheet of notebook, paper, fine. You didn't know today was going to be a good day. You not only got the Be Out Break story, but now we're going to do our arts and crafts. We only do that once, so enjoy it. This is our arts and crafts day. So everybody's got a sheet of paper, any kind of paper, it doesn't matter, guys, it's a sheet of paper. Whip it out of your notebook. Okay? Now, I want you to tear, and we're not measuring, we don't have time, we're doing the best we can. I want you to tear whatever size you want, but tear a square out of a corner. So just tear a square, as close as you can get, doesn't have to be perfect. Please, we don't have time, we're not measuring. Tear a square, whatever size you want. Okay? Once you've got that done, tear the same size square out of the other corners of the paper. So you're going to take the same size square out of each corner of your paper. Nobody's grading this, folks. Just do the best you can. Rip them out. Let's see what you got. So you should end up, you know, you got all your corners ripped out. Your corners will be a different size than mine, and that's the point of the problem. So that's awesome. Tile squares are really good. I love it. Once you get them out, then I want, these are like gonna be flaps. I want you to fold these flaps up. So like these flaps you've got here, fold them up. Because what you are doing is creating a box with no top. Isn't this fun? Now we are ready for the really fun part. Everybody's making your boxes, you're folding them up. We all started with pretty much the same size piece of paper. I mean, I think most of you use notebook paper. I use regular, same size paper. I want you to look at something here. Won't you look at my box? Won't you look at Ellen's box? Whoa, they are not the same. We started with the same size piece of paper. We have the same directions, but these boxes are not the same. This is one of the most famous, it's in every pre-calculus class you ever take in the whole world, everywhere. Everybody does the box problem. That's what this is. What do you think, in your life, what do you think I would want to know? What size corners I should be cutting out to make the box hold the most? Think about it. If I had a big bag of M&Ms and I walked around and I filled all your boxes with M&Ms, they wouldn't all hold the same number of M&Ms. Would you agree with me? Some of them are going to hold more than others. And it all depends on the size of those corners that you cut out. So here we go. We have a piece of paper that is 12 by 15. We have cut the corners out just like you just did. So it was 12 by 15. You cut these corners out. You don't know how big they are. We'll call them X. They're squares though. They're squares. So we cut them out. We folded up the flaps. You can visualize it. You folded up the flaps and you made your box. What size corners should be cut to yield a box with a volume of 125? So we want to write an equation for the volume of the box. The volume of the box, E of X. The volume with X size corners cut out. Tell me about that. What's my equation going to be for the volume of a box? Length times width times height, bless you. Length times width times height is our starting point, right? So let's do it now in terms of our situation. What do you think, Josie?
X times 15 minus 2x times 12 minus 2x.
15 minus 2x, 12 minus 2x and x. You're exactly right, Josie. Order doesn't matter. I did it in this order because I had no previous typewriter. Now, can somebody tell me where she got the 15 minus 2x as the length of her box? Raina?
Was 15, but you
Cut an x here and an x here. So this thing is 15 minus 2x. And the same thing here, we cut out this one and this one. So this is 12 minus 2x. And then why is the height x? Because when you fold up the flaps, doesn't this become the height? And that's your x. There's your formula, nicely done. What size corners will give me a box of 125? A volume of 125. What am I gonna do? So I'm gonna put 125 in for the volume. And solve this equation. Now, it is not quadratic. Everybody recognizes that, right? I would not FOIL it out. You absolutely could, but I'm going to do it on my calculator anyway, and the calculator doesn't care about parentheses, so I'm just going to leave it. So in my calculator, I'm going to type, one of my equations is going to be 125, and the other equation is going to be this. So y equals 125 is one of them, and 15 minus 2x. 12 minus 2x and x. Now, I have no idea what the answers are. I got something that looks straight. There's a line, well, it looks like a couple of lines. That's what I see. I'm not worried so much about that. Although there is something that's concerning me. I can only have answers between what two values? In other words, x, which is the size of the corners I cut out of this paper, x has to be between what and what? So I better think about this before I look at my answers, because I don't want to have a bad answer. What's the smallest x can be? 0. Now, x can't actually be 0, because if x were 0, I wouldn't have a box. But it can be anything bigger than 0. What's the biggest x can be? Why is 6 the biggest that x can be? Because I'm taking a chunk off each side, and if I only have 12, then 6 is the biggest I can take off. Okay? So, I don't care how you want to adjust your window. I am going to go back and I'm going to look at only the x's from 0 to 6. And I'm going to change my, I had altered my y's before, so I'm going to put them back to regular. And I think I'm going to go for a point of intersection, so I'm going to have to make my y's bigger than that. What are we going to make our y's? Maybe 0 to 150? Let's try that. So, I set my x's from 0 to 6, and I set my y's from 0 to 150, because one of my equations I forgot was 125. Did you now see something that looks like this? It comes up, answers to the question. So here we go. Second calc intersect. First curve over here somewhere. Second curve up here somewhere. And I got that my corner could be 0.942. We'll do it again. And that time I got 3.778. Is that what you got? What size corner square should be cut to yield a box with a volume of 125? The answer to part A is X is either 0.942 inches or 3.778 inches. What if we want bigger than 125? More than, wouldn't the, this is A, wouldn't B be just in between those two things? And then C says at most 125 inches. So tell me about that. At most 125 inches. That's this, right? So, am I gonna open or close my zero? Open. X can't be zero in this problem. Right? What happens if X is zero? You no longer have a box, so it's not gonna be zero. So zero and then 0.942, bracket or parentheses. Bracket because it says at most 123, or this part, which is what? 3.778 parentheses or bracket, comma, 6. The end of the problem is 6. You can't have an X bigger than 6. All right, I got one more thing to give you. Please do not leave the room until you have this. We have one more section. In the new book, there's another section. So I want to go ahead and give this stuff to you now. So it's one page of notes and one page of homework. P7 is due on Friday. P7 we just finished. Due on Friday. Wait. Please don't go till you have both of these papers. You need 2 papers. I'm handing them out one at a time so we don't get confused. Your boxes, if you want to keep them for sentimental reasons, that's up to you. Otherwise, put them in the recycle. I am giving you, so everybody's got the notes. Here comes the homework. This is for P8. You already have P7. P7 is due on Friday. Math leagues sign up on Friday. Hope you feel better today. So glad you're here for the box problem now. It's always the highlight. It's gonna come back, by the way. There will be more boxes. There you go. All right, you can go. Everybody's got 2 papers. Everybody's got notes and homework for the next section. Please don't leave the little squares laying around. See you Friday with your $4 or your $18.